Hello everyone, welcome to testing technique session part 1. Today we will be discussing black box testing techniques. Uh, so this we will be covering in 3 sessions. So today is session 1. So first of all, what is black box testing? As you all of aware that black box testing means the tester don't have any knowledge about the internal implementation of the project and or website. He doesn't know what is the uh, implementation, what is the structure, and what is the logic behind the uh, project under the test. Only thing he is aware is the what is the input and he can see the output. So based on that, tester test the website. So today we are going to discuss those black box testing techniques. So black box testing is defined as it is a behavioral testing, is a software testing method in which the internal structure, design, implementation of the item being tested is not known to the tester. These tests can be functional or non-functional, though usually functional. So under black box testing comes functional as well as non-functional testing. Testing means performance testing and stress testing, load testing. All these comes under the non-functional testing. So we will discuss these black box testing one by one. So this method, now what is the advantage of doing black box testing? So through black box testing we find the following category of errors: incorrect or missing functions, and through this uh, interface errors, we can test interface errors, error in the data structure or in external database, behavioral or performance based testing, and initialization and termination error. Then type of black box testing techniques. So under this falls 6 type of testing techniques: equivalence partitioning, boundary value analysis, decision table test, state transition testing, use case testing, and error guessing testing. So this I will try to cover in 3 sessions. So today in first session I will cover equivalence partitioning and boundary value testing. Okay, so these two I will be covering in the today's session. Now come to the next slide. Now what is equivalence class partitioning? Equivalence class partitioning is also known as equivalence testing and its short form is ECP. Now what is its use? Let me tell you, explain this. So equivalence class partitioning, it is used for input fields which accept range of values. Range in the sense like some field accept like age accept 18 to 35, or there is a field like fee which accept only 0 to 500, or there is a date of birth field which accept the year between 1980 to 1980 to 2020. So such kind of, for such kind of fields we can use equivalence partitioning because it have a range type of values. As the name suggests, ECP is to divide a set of input data into partitions or classes based on the condition identified and select one data from each class to create a test case. First step in equivalence partitioning is we divide the data into the small partitions, and after that we pick the data from each test class and create test case accordingly. So it reduces our testing efforts so much. And if, since the exhaustive testing is not possible, we can't test each and every for each and every data. So this ECP and BVM, binary value technique, BVA, binary value uh, analysis are very useful. Equivalence class partitioning can be applied to all level of testing. Means we can do it in for unit testing, integration testing, and system testing. Next is, so let me illustrate this with the help of an example. Suppose we have a student need to fill exam form and there are the field name, age, fee and submit. Let's suppose we want to test age field with the help of ECP technique, equivalence class partitioning technique. So let's suppose there is a limitation, the age field accept range between 18 to 35. So only those student can fill this form whose ages lie between 18 to 35. So as you can see, it's difficult to test for each and every age. So what we will do, we will divide this range 18 to 35 in partitions, various partitions like valid partition range and invalid partition range, that you will see in the next slide, like how we will divide this range into various partitions. Okay. Let me move to the next slide. So if we try to test this age field with the help of equivalence class partitioning, what we will do, we will apply one valid and two invalid conditions. Age between 18 to 35 consider as the valid age. System should accept the age. Whereas age less than 18, that is 17, and more than 35, that is 36, is invalid system date, invalid age. So system should display error message here. Okay, so whenever I enter this date, this age between this range, it will valid, and if I enter date below 18, it show invalid alert message, and similarly above 35 also it will show invalid alert message. So here I divided the input range 18 to 35 into three partition. One is valid partition, and below 18 is invalid, and above 35 is invalid, right? So we have our testing effort reduced so much. So only we will pick data from each one data from each range and consider that it will work for valid for as per the same behavior for other data. Suppose I will randomly pick one field, one data from this range. Let's suppose I pick 26. If it works for it, then I consider that it will work for all the valid data. Similarly, I will pick one data from below 18 range, that is 0 to 17, and let's suppose I pick 16. If it show alert message for this age, then it will display alert for all the messages, and similarly for 36 also it will show invalid alert message. So as you can see how my testing efforts are reduced. So we will build our test cases as per that only. Next test case technique is boundary value analysis. Its short form is BVA, and it is used after defining equivalence class partitioning for the data range. We uh, we test as per the binary value analysis. So it is suitable for those fields which have minimum and maximum limit, and it is defined as, it is also a black box testing technique, or also known as specification based testing technique. This technique is used to test the boundary values. It is widely recognized that input value at the extreme end of the input domain cause more chances of error in the application. So it is expected that the input at the extreme ends uh, will give more error as compared to in the valid in, as compared to input in the middle range. So the second step after ECP is equivalence class partitioning is boundary value analysis. We test our input around the boundary value. So basically you can say boundary value is analysis is helpful for negative testing and stress testing, whereas uh, ECP testing is useful for integration testing, unit testing and system testing. Now, what is boundary value? So, before understanding boundary value analysis, you should know what is boundary value. A boundary value are those that contain the limit of variable upper and lower. For example, there is a student registration page and age field is there. Same age field now we are going to test with the help of boundary value. In this form, uh, there is a age field. Now same age field where age lies between 18 to 35, we are going to test it with boundary value analysis. We divided the partition. Now along each partition we will test this age field around boundary values. Now a boundary value are those that contain the limit of the variable, and there is a student registration page and age field is there which accept the age 18 as minimum and 35 as maximum. Here 18 to 35 are the boundary values for the field. Okay, so as I said in the beginning that this technique is used where maximum and minimum limit are defined. So this is the range where minimum limit is 18 and maximum limit for age field is 35. Now, how to do boundary value testing? So, we know the minimum and maximum value. If the field to be tested accept the range of value from A to B, here A is the minimum value and B is the maximum value, then we test the field by around these values A minus 1, A, A plus 1. This is the start minimum range data, and B minus 1, B and B plus 1. So these six type of data we test around the boundaries. So let's suppose this is our data. 18 to 35 is the valid range. These partition we did with the using equivalence class partitioning, and below 18 is 17, 16 and 15. This is invalid range and this is also invalid range. So here boundary value minimum value is 18 and maximum value is 35, which are valid. And using this technique, boundary value technique, for this formula, we have to find the range, and on the basis of this, we have to write the test cases. So range here is along, if we calculate the range along minimum boundary, then it is 17, 18, 19. A minus 1, 17. A is 18, boundary itself, and A plus is 19. Similarly, for maximum value also, we will find out the test data around the maximum boundary as well, which comes out to be 34, 35, 36. So, we can test our data for these. Now, so as per boundary value analysis, we have these three test cases. Example. So first of all, we check the age field by entering the value which is not in the range, that is 17 and 36. Okay. And after that, in the second test case, we check the age field by entering the exact boundary value, that is 18 and 35, which are valid. Similarly, we check the age field by entering the value which is within the boundary value, that is 19 and 34. So, as per this technique, these test cases are sufficient, and it will help us in doing negative testing. And as we as I told you in the beginning that there are more chances of finding error around boundaries, so it is the best technique. Let's summarize these two techniques. In boundary value analysis, testing is used when practically it is impossible to test a large pool of test cases individually. Okay, when we have a large pool of data and it is impossible to do exhaustive testing as the data is too large, then we use boundary value analysis technique. Two techniques, ECP and boundary value analysis testing techniques, are used. In equivalence partitioning, first we divide a set of test conditions into a partition that can be considered. In boundary value analysis, we test boundaries between equivalence partition. After doing partition, we do testing around the boundaries, that is minimum and maximum limit. After appropriate for calculation in intensive applications with variables that represent physical quantities. So this is all about the two testing techniques, boundary value analysis and equivalence class partitioning. Today we discuss boundary value analysis and equivalence partition technique. Hope you understood it. If you have any doubt, you can message me and you can inbox me or you can email me, and for the video I will upload this video after the session, and you can subscribe my channel to in order to get notification about upcoming videos. Thank you. We will meet in the next section. Thank you. Bye bye.